and you're at our monthly webinar. My name is Deborah Henderson, and I'm Vice President of Programming for and your host today. Can we move on to the next slide, please? Right, today's session is sponsored by Infoset. We want to honor our sponsors by mentioning them in our webinars. And Infoset has been with us for about 5 years. Please see their website. Today, we're talking with Blair Kinger and Keewal Dhariwal on the dire need for generally accepted data management principles, or GADMP, the concept of which has been borrowed from the generally accepted accounting principles, or GAAP, for data management community. Blair and Keewal are in the throes of finishing off and publishing their book with a renowned guru as well. With a Bill Inman, how can I forget his name? So this is also an introduction to their forthcoming book. Next slide, please.
That's all the slides we got.
This is all the slides we've got. So thank you very much for the slides, and we'll hand it over to Keewal and Blair.
Thank you. Well, I'll start off. I'll share my screen here, and hopefully you can see this. There we go. Everyone able to see this slide?
Looks good.
Yes. All right, thank you. So generally accepted data management principles, as Deborah stated, follows in light of the need for us to have in our industry, right across both data management and application development, some kind of general principles that follow the same route as the accounting professions or the engineering professions have built over the years. And we're maturing as an industry, and we need to move on to having these types of generally accepted principles available for our industry, and to improve production and ability to build systems on time and on budget. So Blair Kinger is my co-host, or we're co-authors. Blair is with Method 1 Enterprise Software, which is a company based in Edmonton. And myself, I'm also based in Edmonton, and I'm one of the founding members of DAMA Edmonton chapter. I'm also the executive director for ICCP, and I'm on the management advisory board for the Alberta Machine Intelligence Institute at the University of Alberta. So a little bit of a background on the agenda, what we're going to do today, background purpose, why our current approach to enterprise software is broken, what are the objectives of a new paradigm that we're proposing, discuss the key principles of the new approach, and also look at where are we at, and then move on from there, where do we go next. So from an experience basis, Blair has been involved at a technical level in creating enterprise systems for over 40 years. And he's worked with all types of industries, associations, unions, oil and gas companies, healthcare providers, municipal government, retail, and service providers. So he has a very, very broad range of experience in building enterprise systems, and is an excellent subject matter expert and an industry leader in that respect. Myself, just a little bit of introduction. Academic, I've just about taught in a lot of different universities all over the world, and I've worked all over the world as well. I'm currently still doing a little bit of teaching and coaching through a U.S. university based in Albany, New York. Obviously, I'm working with the Alberta Machine Intelligence Institute, and the courses I've taught cover from hardware, software, operating systems, all the way through a lot of stuff, 40 different courses over the years. And I've just finished a 12-week teaching course on blockchain, trying to stay current And of course, I've managed research centers at a number of universities over the years. On a consulting basis, I've had my consulting company running since 1980, and even prior to that, I built applications with insurance companies in the UK, and I've worked from accounting companies through municipal and federal, as well as provincial government departments, training them and educating them on ERP systems as well as standard applications development. And I've also trained a lot of different companies like Infosys out of India, Tata Consulting company out of TCS out of India as well. They're two largest software companies there. IBM, of course, set up a number of training sessions with IBM on programming languages like C++ in the past. And there are many other companies. I'm not going to mention all of them. And from an international experience, I have worked in all these countries. So I have had significant experience in working from China to New Zealand to Europe, and right across the world. So some of the biggest success stories were, for example, I set up training in Cuba for the college. We're still there since 1998 when we first started training them on infrastructure as well as software development. And so, as I said, I've worked right across the world, multiple languages and multiple locations, and I've seen the same problems in software development in every country that we have, as well as our own country here in Canada. So, why are we where we're at in our industry? That's really the main question, and it boils down to broken promises. What we've done is we've tried to do systems, and I applaud all the efforts that of industry, but however, we lack data integration. We have really failed on building systems that are able to move data between them. And so as a consequence, our current approach to enterprise software, and this has been our approach from day one, has affected companies in many different ways. The inefficient administration and the cost of this inefficient administration is incalculable. It's billions and billions of dollars, maybe trillions of dollars. There's also this heavy dependence on spreadsheets, and they are marvelous technology to help us do a number of things, but they are just not centralized in any way. They're not shared. And when people leave, sometimes the spreadsheets leave with them from their organizations. So the data integrity issues and the data failures have resulted in huge amounts of lost revenue and, of course, increased liability for the companies. It's just that perhaps they haven't been caught in that trap over the years. There's also this huge difficulty in compiling accurate management information. And so we try and build all these new kinds of technologies, Databricks, Snowflake, MuleSoft, all of them try to integrate data, but they're all disparate systems that they try to pull together into some way of providing some accurate management information. But data is really, really hard to pull together and make available in a accurate, precise manner for organizations. So, and then over the years, our biggest broken promises are in both design and time and budget issues. We've always been, our projects have lasted longer than they should. They've always been over budget. And then we get into this huge, huge maintenance issue because we didn't design things right from the day one or from the base up. So looking at more broken promises and then looking at solutions, how have we tried to fix those problems over the years? So I have a very, very nice slide that, and I'm not going to show it to you here today, but MRP1 was materials requirements planning in our manufacturing companies was one attempt. MRP2 is another environment where we try to integrate some data together, and then ERP where we try to integrate all of the functional departments in our companies. And these efforts have been over time, they've been expensive and they're risky, and often they've been vendor controlled. In fact, always vendor controlled, and the customizations issues that arise when different versions are updated. And of course, there's this recurring cost for rework that just boggles the mind, but it's continuous, and no one's been able to solve this issue. We also have new sort of efforts at cloud-based applications, software as a service, data as a service, network as a service. And of course, we begin to run into access issues. We begin to run into fees for services. Uh, Even when we're aggregating into data warehouses, when we reload data, we run into all kinds of continuing increasing costs. And the software companies love to take us to the cleaners. So all of the providers, they still present the same old problems. They have not fixed the root cause. And so consequently, we think that all this cloud-based applications is still not going to solve the problems that we have faced historically. And of course, things like electronic data interchange, EDI, again, we have issues around varying data attributes. We have primary key issues. We have every system you ever built has the same primary incremented integer keys, and so you always are constantly having trouble when you try to integrate systems between organizations. So, and then all systems have an ability to update their own systems, and then how do you if you've integrated anything, how do you make sure it's kept consistent? What's the golden record? And we really have not solved that problem. There are lots more powerful software development tools, and this sort of goes back to the silver bullet approach. We try to see technology leapfrogging other technologies. We want to do fast replication development, but we still have not solved the integration problem. And so rather than improving our situation, we actually exacerbate all of our problems because we keep increasing complexity, because we keep building lots of new systems, but they're not integrated. So all of the different software and database and different version environments just creates increasing complexity and doesn't get us what we need to have in our professionally built, engineered applications. So let's look at some more problems. How we try to fix these problems again. Well, we've had data warehouses, and we're getting cloud data warehouses with Snowflake and others. But these are always point in time data sets, and you know we try to integrate the data for management reporting, for analysis, but there's a continual recurring cost. There are costly updates, uploads. I mean, companies charge for every time they upload. I did a consulting job for Ford, and their data warehouse, when they uploaded all the operational database material to the data warehouse, to the ETL process, it just slowed the entire network down for the whole day. It was just crazy amount of time. So there are different databases, there are many sources of conflicting data. So data warehousing activity is still complex and very, very hard to do at times. And we still haven't solved the problem of integrating data properly. So look at machine learning and AI. What will that do for us? Well, it will help speed up our tasks, but we still require clean data. We still require removal of biased data, and we still have same problems with the multiple unintegrated databases. And all this is going to do is speed up our ability to have bad data. Methodologies, well, we've used architectural methodologies to try and architect our systems, but they seem to be too focused on within the company and not across companies or across supply chains. So they too don't solve the problem. So if each certified group produced a system architecture based on siloed systems, then it doesn't solve the problem. So siloed systems is a continuing problem for us throughout our industry. Master data management. Well, this is one of the areas that we has tried to foster integrated data and data definitions, but it's still a problem because there are thousands of systems, and because these MDM efforts fail because they're not all integrated into one ERP. Many organizations, large organizations, have siloed what they call best of breed applications for other parts of their business. And so consequently, you run into the same issue of integration. We have universal data models. People like David Hayes and Len Silverstone have built universal data models or centralized data models But these are owned by their organizations, and they too don't allow for an evolution of those models. There's no committees to update or broaden their applicability. So they are standalone. They're much like SAP sells their own version of a universal data model within their ERP system. So let's look at another issue. What is the root cause of all of these problems? And I have to step back, and as an educator for over 40 years, I have to look back and say, oh my God, it's really the educators that have been part of the problem. And so I've worked in model curriculum committees since the 80s, and we've tried to keep our computer scientists, our computer engineers, information systems builders, information technology people, and database administrators, data scientists, we've tried to keep them up to date with new technology, but we didn't fix the root cause. And the root cause these academics have not fixed is this issue of silo development. Every instructor, every professor, every professional development training organization keeps teaching silo development. And the reason is each of them teaches segmented different courses, programming or systems analysis or application development or systems architecture. And because of the time available and because of the lack of thinking in thinking about these root causes, they tend to teach just let's build a database, let's gather some requirements, let's use an incremented integer key, and boom, we're done. And so as a result, all of these courses do not teach systems integration properly, and they don't have a way of solving this root cause. We want to try and solve this root cause by having the educators and the curriculum committees look at what we're proposing today. So at this point, I'm going to pass it over to Blair, and he's going to talk about where we're at and how we're going to solve these problems. So Blair, your audio's off, and please take over.
Just 1 second here. I'll just get to the right place here. Okay, so yeah, I have been developing software a long time. I have, it has been like 40 years. In fact, it's been, actually, I'll step back just a little bit before that. I went to NATE, and when I was going to NATE, that's where I first met Keywall. So as old as I look, anyhow, there was Keywall, and at any rate, so over those years, I was developing a lot of systems, but there's really kind of two kind of profound projects that I got involved in, and they really kind of set me on this path of trying to deal with, our integration issues. The first system was a system for the Alberta government, and I took over project management for this system, and the system was over, it already been kind of 3.5 years into the development process. And I think what really shocked me, first of all, was how much effort we spent on trying to integrate this system. It's like a central registry system, and it connected to a bunch of other systems, and it was just an inordinate amount of time to try to integrate it. And I guess because it was government, we had the budgets and the money to do it. I don't think in the private sector we would ever rationalize it, to do that. But, so it was really, that was kind of outstanding to me that, it was a significant issue. And the other thing I saw is, like, in the government, there was a lot of custom systems. And I think that you see that in certain environments where they do have a lot of custom systems. And there's a pattern, in terms of how those systems are constructed. Effectively, they're given a scope. The team is given a scope. They're given the requirements that they need to address. They design a user interface, and sometimes they create an application framework to support that user interface. They construct a system. In the process, they create a database, and that database is as unique as a fingerprint. It is really what they like for naming conventions, what they like for, like we see things like temporal data, like time sensitive data. They will decide how they want to manage it. And it's really a custom created effort. And then eventually they'll throw it into the mix of systems and then try to integrate it, only to figure out they can't, and or they can't easily. So the second big system, or the second, this was the real impetus for me, but it was, I got involved in an oil and gas system. And in that oil and gas, or actually it was an oil and gas project, but we were helping an oil and gas company find their missed revenues. And, you know, it just, again, it seems kind of astounding to me that that would represent a project. But the reason it did was because they had all these individual systems. It was, you know, always this best of breed approach to their systems. They had like 30 different systems in their organization. My job in that process was, I was kind of like the data architect guy. And so I went in, downloaded all of these systems, reverse engineered them, produced a corporate data dictionary, put like a common language over, you know, everything, developed tools to mine the data, connect the data. And, you know, in the end, we ended up finding $7.5 million that they missed in billing. Like, you know, and it's just like, wow. And it was really, it was because data gets entered into one system, and then it's a manual process to move it to another system. And then they use a spreadsheet to reconcile between them. And, you know, so it's really the same process. And when you reverse engineer systems, like I did, you get to see how they're constructed. And it's exactly the same process. You can see, you know, they're given a scope, they create an application framework to, you know, and a user interface for that system. They design it, build it, create a database as unique as a fingerprint, throw it into the mix, you know. And you might ask, like, why are they so hard to integrate? Well, it's because, like, in that scenario, we had oil and gas data. And, you know, so there'll be, you look at oil and gas wells. Well, one system has 30 attributes. The next one has 50. The next one has 17. They have different numbers of attributes in each system. And even when you find a common one, like, oh, geez, oil well status, perfect. Well, one system has 5. One has, you know, 3 statuses. Next one has 6 statuses. So there's absolutely no way that you can just take data, you know, that comes into one system for, you know, like, let's say they create a new oil and gas record, and just go have it update, come into that system, go bing, 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 and update every other system in that environment. And then what happens when one of those systems update data? You know, it's got to go bing, 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 and update every other system. So it's really, you know, we'll spend tons of money on trying to integrate these systems. And even the word integration is kind of loosely used, because it's like, if we integrate systems on one table, they're considered integrated. But, you know, in my experience, when you look at master data, which goes across all these systems, it's a high percentage. It's like 50%. Like when you consider all your reference tables, lookup tables, you know, in your master data, it represents, you know, I would say the bulk of the data that exists. So, you know, if these systems were truly integrated, they would be able to, you know, share kind of like all that kinds of data. So this diagram, this picture here is just kind of shows what I think a lot of organizations will see when they look at, you know, their systems. They see all these little pieces, but nothing will fit together. So, you know, so really it comes down to, we have educated a whole workforce in creating silo systems. You know, they're not educated in terms of how to create systems in a way that we could not only integrate them within an organization, but beyond. You know, so, you know, we've come a long ways, and we've done some amazing, you know, automation, you know, to help us get to where we are. But we've kind of hit the wall in terms of, you know, how far we can go with it. And so, you know, so sometimes, like, one of the big solutions is, you know, you'll see an organization, they've got all of these systems, and then, you know, they say, well, we just need to get a bigger system, so they'll get a bigger system, and but they'll implement a big ERP system. But the big ERP systems we know they can be extremely expensive. In fact, there's it was a newspaper article that kind of struck me. It was the Alberta government, and they were implementing a healthcare system, and it's $1.6 billion. Like, I mean, we've become numb to those numbers. And, that's like, I think I figured out this like 2,000 resources for 5 years, at $100 an hour would represent, that kind of a budget. But, so they can be prohibitively expensive to the point that they create a tremendous amount of risk for organizations. And you'll hit other issues where the more they customize that system, the more they'll struggle with upgrades. And it's it makes it difficult for them to quickly adapt and adapt the system to meet unique needs. And really, it's just another silo system. I mean, really, when they created this ERP system, they were given a scope. They designed a user interface to produce an application framework to support it. And by the way, the ERP vendors have invested a lot in their application frameworks. But then they create this system, and then they roll it out, and its database looks like nothing that's ever been created before. So so it really kind of speaks to it. But the other issue is, once organizations get a system like this, they can't easily switch to another vendor. They're kind of, once they've invested as much as they have, they're kind of stuck that way. And there's really, these systems can only get so big before they fail. And sometimes I think that's hard for maybe people to realize. They look at, well, the system, if functional points are like widgets, if it cost us, 20, if it cost us, $10,000 to do 1,000, it's going to cost us 100,000 to do a 10,000. Anyhow, I got those numbers, but anyhow, it's not like that. It is every one of the functional points, when you put one in, affects other functional points. And I kind of have an analogy where it's like a pinball machine, and all the posts in the pinball machine represent a functional point. And so you put another post in there, for this new functional point. Well, and then you drop the ball in. Every time it hits a post, it costs $1,000. Well, in a small system, it hits it hits 4 posts and drops out the bottom, no big deal. When you get to the big systems that have thousands of functional points, when you add one functional, there's at some point you're going to add one functional point, you're going to drop a ball in, it's going to go ping, 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 and it's never going to drop out the bottom, and so that's the kind of escalation that we can see in complexity. And we are not even coming close to dealing with the needs of conglomerates, where there's large organizations that are broken into many smaller organizations that all need to communicate, like government, where they've got, departments, and, you could never take just one big ERP system and bring it into government and then have it, that it's this one massive system that meets all the needs. So, because of the way we create the systems, we can't create smaller systems for those entities and then have them all communicate. So that's really, some of the key issues that we're looking at. So when we step back, really the vision for the enterprise software that we're talking about, we call it, we thought it was a pretty good name, Mesh ES, Mesh Enterprise Systems. We really like the word mesh because when things mesh well together, they work well together. And the vision for these mesh systems is that they will work well together. Mesh is like interwoven, and these systems will be interwoven. And you think of mesh like cloth mesh. If you throw it over an object, it takes the form of that object, just like these mesh ERP systems will be able to be customized to the unique needs of the organization. And they will be like a secure, we need to have some kind of a secure data exchange mechanism that allows us to move data between them. They need to be open source. So because we've seen great powers in the open source community of being able to build on things and make things better. But I think that we need, the key thing there is to start with a strong base. And we need rapid application development. And, that's going to come about, by having strong frameworks, by being able to share source code and the like. So, so if we were looking at, let's say we were implementing mesh ES systems in government, there'd be a mesh ES system at the top of government, they would maintain a lot of the master data. They would push that down to the departments. The departments would have their system, of course, and each system would deal with everything for that entity. It would track all their finances or their contacts, their activities, their everything. And it would be customized to their unique needs. And then they would be pushing data down to their, to their branches in this case. And then because everything is driven, from a top-down perspective, we could be able to have data exchanged and communicated between all the systems. But more importantly, we could take data and roll it up from the very lowest levels to the highest levels for reporting. And so that's really the goal of what we're trying to do. Now, this is government, but this also applies to, let's say we're in the oil and gas industry. You could take, an oil and gas service provider could go out and implement one of these mesh ES systems. They could go out, do work on an oil well. They could, wand in a QR code for that oil well. They could push their data to the oil and gas company, which would include information about that oil and gas well, the activities they perform, the finances that would go into the oil and gas company, connect into, all their data, and then they could push that to their partners. So it really applies to, kind of a lot of different environments. Healthcare is another big one, but at any rate, so the key objectives for this new paradigm, well, we need to be able to easily move data between systems, take large systems and break them into systems that can communicate. One of the big things that we'll see in what I call the old paradigm is we implement systems by function. It's like, oh, we need a purchasing system, we need a contract management system, we need a whatever business function we want to automate, and then we go find a best of breed package, and that's how we break systems into smaller systems. But that doesn't work because each of those are developed in silos. So this is more taking like a business unit and then basically giving the business unit a fully functional system to meet all of their needs, and then connecting that into all the other business unit systems. So at any rate, we need to allow us to share functionality between systems and leverage the power of the open source community. So it's all well and good to say that that's all the great things that we need to do, but like now, how are we going to do it, right? And so that's really where I started a journey, and I started, this is back in 2017, and went and started formulating this approach and using kind of some of the experiences I'd had previously, and then with trying to achieve this new objective. And so one of the first, so we came up with 5 key principles, and it was actually around that time that I got QWall involved. I just said, hey, QWall, I think we need better education for students in terms of how to create enterprise systems. So that's where our conversation started 5 years ago, I guess. But so with core data models, core data models represents the common data we see in every organization. And, so when you look at every organization, well, they got contacts, they got finances, like transactions, journal entries, budgets, they've got assets. Lots of them are interested in their assets, activities in terms of who's performing what for who. My first experience with core models was in the early 1990s. And so at that point, I'd be developing systems for, I guess, 9-10 years, 8, or, and I went and I said, what would happen if all the systems that I've produced to that point, what if they were all in one master data model. And when I started taking all these different systems and then building them and then modeling them out on a whiteboard, then all of the common data started to pop out to me, like in terms of, wow, I got contacts. Well, this system would, okay, contacts. And so I went through this exercise. It was actually, kind of funny because I I'd write it down on a whiteboard, and then I just thought I'd struck gold. So I'd like wipe it off the whiteboard so that nobody, yeah, just anyhow, to me, it was astounding, and I was just thinking it was a secret to creating systems. And so we started creating our systems back then, based on those core models. But so at the core of these entities, it's all the attributes that we would see in kind of most systems. And we think of core models, and it's not a new concept. I mean, when the ERP vendors are going into an organization, they have educated their people in terms of what their core structures are, and educated them in terms of how to extend those core structures to meet the unique needs. They don't go in and say, oh, what, you have finances, you have transactions, journal entries, what, you have contacts? No, they have their core structures to deal with that type of data. And even though they're going into very different organizations like banking, healthcare, manufacturing, retail, they are extending those core structures to meet the unique needs of whatever industry that they're dealing with. One of the other really critical things, I think, for core data is, we've seen these models in the past, and then there's like a model and it would fill a wall in terms of, its complexity. We really need to put a threshold on it. And it's really like, if it in the core structures that we look at, if it's not in 80% of the systems, then it's not in, so we're not having, the idea is to have a solid core of the common things that we would work with, and then extend that core. If somebody wants to take that and extend that, in their given system to track additional data, then they're more than open to do that. And, and then the core structures get used by an industry, and then they will have the same principles to extend the models for their industry using probably the same kinds of concepts of a threshold. If it's not in 80% of the industry systems, then it's not in the model, kind of a concept. So, in terms of why the core structures are so powerful, well, we've witnessed it since the early 90s. They're highly static. And so, we can go in and create financial software as an example. And you know what? 50 years ago, probably more, we had transactions, financial transactions, and for a financial transaction, we kept the type of transaction, the description of the transaction, the date of the transaction, the status of the transaction. And there was certain core data that we kept about that. And then we had journal entries. Well, the journal entries were associated with the transaction. They were, they were linked up to a chart of account. They were linked up to a cost center and all those things. And so that is true today. It was true 50 years ago, and it'll probably be true in another 50 years. So because they're so static, you can start to create software based on them. They have to be designed in a way that you can extend them to meet unique needs. The core models are powerful because all of the standards get baked into those models. They have lots of features built into them, like, we build in like change history into this model so that, we can have audit logging for any table and keep track of, who executed a command, what changes they made. The models are support temporal, so we can deal with time sensitive data. They have features like, data exchange built into them. So, and as time goes on, we will expand the core models that we've produced to include new core models, like for contract management, HR. And industries hopefully will pick up on the core models and extend their core models to say, include oil and gas or retail or healthcare or whatever it may be. And the other thing is organizations can choose to use what, or architects, they're not compelled to use every aspect of the model. If they can use what aspects of the model they choose, but if they start changing the core model, then they've lost their ability to communicate with other systems. That's really just kind of, what the issue is or what the problem is. So, in terms of how they'll be used, well, of course, they're going to be open source and we're going to be expanding on them. And they need to be baked into our education as things. So students will learn how each of the models work, how to expand on them, how to convert existing system models to use the, to the new core models. And they'll learn why it's important to have, core models in their structures. The next one, the next principle is primary keys. And, as an industry, we have not put much thought into primary keys. What we have is, we have these generated keys, which are like incremented integers, which, is, just it's a 4-byte key. It's an incremented integer. Every time you, I should step back for those who don't know, like the primary key identity is the unique identifier for any given record. And it's what allows us to connect data together. So, if I'm a contact and I get added to a system, I will be given a primary key, and then any data that is captured about me, that primary key will be recorded as a foreign key on those records. So hopefully that's just a quick description of it. But so for incremented integer, again, developers love them. They're fast. I'll actually get into each of the benefits of them in the next slide. But GUID, that's like it's like this random key. So if you generate enough of a random key, then you should never see a duplicate for it. And there will be, different forms of that key, but they are extremely big. And, and it's like, it's kind of like if you said, if I pick a number between 1 and a quadrillion, and then, store that number, the chance of me, recording that number again is 1 in a quadrillion kind of thing. So the other type of key is natural keys, and they can be like a single column or multiple columns. So they'll take, keys that, where you've got an address, it's got maybe, address is a good one because there's no natural key anyhow, but there are composite keys where you can pick a number of fields and then that can make up a composite key. So some of the issues, well, I'll start with composite keys first. They're bulky when you start to record them in indexes. They're not available for all types of data. So if you look at a natural key for a contact, you can't use the name, name, birth date, gender, and combine those 3 fields and then, make that a key. You have to actually generate one. It's really difficult to create common code, like framework code based on, composite keys when everything is changing everywhere. They don't guarantee uniqueness when you start transferring data between systems. Incremented integers, well, they're fast and they're small and people like them for those reasons, but they don't guarantee, again, they don't guarantee uniqueness when you start transferring data between systems, because every system is typically starting at the number 1. And so the same data will have different IDs in different systems. GUIDs, well, they are bulky. You couldn't really produce a system and use GUIDs on every foreign key and primary key. I mean, you could, but there would be, performance implications for that. GUIDs create issues for storing data. So when we store data, especially in SQL databases, they like to store it sequentially, one record after the other, neatly organized in the database. And with GUIDs, well, they get spread all over the place. So that creates issues in retrieval, but it also creates, it bulks up the storage, and to the point that people will actually take an incremented integer ID and put it on the same record and then use that as the primary key. And anyhow, so they can try to work around those issues, but they are an issue. One of the big issues is, and again, this gets back to how we create systems. Developers get to choose whatever they want, and sometimes you're going to see all 3 in the same system. So, when you start trying to move data between systems, but primary keys create a big issue. So the objectives for the new key is you must be able to generate it once for a record and never have it change no matter where it goes. So that applies to master records, transactional data, whatever it may be. Every record has to have a key. It has to be unique, and you need to be able to transfer it anywhere, no matter where it goes. It has to be as compact as possible. So it can't be like 16 bytes. Like the GUIDs. It can't be, like the composite keys. We have to be flexible so that we can change this, key in the future. Like we see TCP/IP went from version 4 to version 6. It's got to be kind of those kind of a concept. It's got to be consistent for all tables and all systems that follow this protocol. The new primary key, well, we came up with a kind of interesting idea. We call it a DNA ID. It's like, it's like your DNA. Your DNA identifies your origin. It identifies where you came from, and it's completely unique to you. And this, to accomplish that, we have a system ID and a record ID component. So the system ID identifies the original system that created the record. So it's kind of like a TCP/IP kind of a concept. And the record ID is combined with that. And it's basically, it uses an incremented integer kind of a concept to uniquely identify a record within a given system. So here you'll see down there a little bit lower, it's 33-1. So if I am in system 33 and I create the first record in a table, then it's going to be 33-1. And the second record is going to be 33-2. So it seems, it seems pretty simple when you look at it this way, but we built in all of the algorithms and everything so that we can keep this, maximize the efficiency of this key, and while making it expansive enough that we can deal with a lot of data. And so the initial format is 8 bytes long. It can store 1.8 million systems, and it can store a quadrillion records, record IDs, within a given table. It's easy for users to reference, when they, like sometimes, like if we were dealing with GUIDs, to represent a GUID, it takes 32 bytes of data to represent a GUID. And that's one of the things that people don't like about them. But with this, it's nice and simple, 33-1. And they would come to recognize I'm system 33. And, so I'm always going to see, these numbers. You can start to reference them in your data or in your forms and stuff. These these system or primary keys are, no matter where you transfer them, they are unique. So we never have to worry about transferring data from one system to the next and colliding on an ID because the same ID was produced in that system. They're unique. So they're unique no matter where. They're useful for record governance, which I'll be talking about next. And so now we've talked about, we're going to produce systems based on core data models. And, so that's going to help us start to transfer data between systems. That's good. And we're going to use these new primary keys. Well, that's good too, because now we can move data between the systems, and the primary keys will always be unique, so that when we're talking about, moving data, for a record that is 33-1 to another system, we know that which record to update. So there's some good things, but there's still a problem, and that's what the kind of the next one is, which is really record governance. Record governance says if every system can update every record, then what's the book of record? So it creates a big problem that way, that we need to have some system own the governance to basically own the book of record for that system, or sorry, own the book of record for that record. And so with record governance, we always know what system is holding that book of record. And so in terms of how it works, it actually kind of ties into the primary key concept. So when we create a record, if we are system number 33, and we create a record, it's automatically going to have system ID 33. So we instantly know for any records that we create where I'm in system 33 and I created a record, 33, I govern it and I don't have to do anything else. So I can just create records like crazy. The only time if we transfer governance to another system, then we create this exception record that tells us we've transferred governance. And so when we transfer governance, a good example would be, let's say you had a membership system. We do the Chartered Professional Accountants Association. So there's a membership system. So let's say that a member got created in the Alberta system, and then that member, for whatever reason, transferred to Saskatchewan, and now that they're in, now the Saskatchewan has governance over that record, and they're going to be the one that make the updates, and everybody else is going to be a subscriber to those updates. And the other key thing about governance is it applies to master records. It's really just the data, the master data. It's not transactional data. We're not, having governance over like a journal entry or an activity record or whatever. So it really does just apply to master records. So, okay, so now we've got the first, 3 principles: we're producing systems on core data models, we're using primary keys, we're governing records so that we know who needs to, or who has the privilege to, or who holds the book of record for it. But we still have an issue with data transfer. And we need to be able to communicate and have these systems exchange data between them. So basically the master data, this data transfer mechanism, it basically allows you, in a given system to go in and identify all the data that they wish to share with other systems. And you think on the surface that's simple, but you get into situations where, we can sometimes share a single record, like a contact record, but sometimes we need a grouping of records, like the contact and their addresses. Or let's say we were sharing a contract record. We would have the contract record. Well, sometimes you're just sharing the header, but sometimes you want this subsidiary record. So you want to see who were the participants, what were the terms, and this is a hierarchical structure that can go down as many levels as we need. And we call those record groups. The same thing applies to systems where, we can have another system gain governance, or not subscribe to a record, but sometimes we have groups of records. So it'd be like, okay, well, we have our retail outlet group. And so when I add in and create another retail outlet, they're just going to go into that group. And as soon as they're going to that group, the system's going to automatically broadcast data to them. And so really when these subscriptions and record groups and all that is being maintained, there's just a process that will automatically go out and it will look at all the subscriptions, look at all the record groups and all that. And it will basically broadcast this data out to all of the subscribers. And we've done it in a way that we have like what we call a subnet, where this kind of similar to a subnet for a network. And so as an example, in the government, well, all of their departmental systems would exist on a subnet. And so they could very easily exchange data between themselves securely without ever having that data published anywhere else. But if they needed to communicate with an outside entity, then it goes up to what we call our master data server, which basically then communicates this data to, between subnets. And subnets are continually connecting to this master data server, very much like an email server, figuring out what master data updates have come to them, and then basically pulling them down into their systems. And so all of this functionality is built into the framework for core data. And so then as we add new types of data, it automatically inherits those capabilities. So now if we extended it to have oil and gas data, now we can do that with oil and gas wells and contracts and whatever else there may be. So there's some of the other features. It could be a single record, or it could be a whole table, or it can be filtered records. Like we might just want to exchange out like an address or home address, or, well, let's say business address and not the home address. So we can have some capabilities like that. And I'm going to step back just a bit here. So in order to prove out all of these concepts, the devil's in the details. And so I ended up actually architecting and creating all of the software necessary to do all this stuff, so that I could actually prove that, that it was possible. And it was in that process that I discovered a lot of the actual details of what we were going to need to do in order to accomplish this. And the intention is not for us to sell the software. That was not, it would be to provide this software. And if people want to create it in other mechanisms, then that's more the open source approach that we'd like to take with this. So, but anyway, so that anyhow, so some of the other things that we found were necessary. Well, when you transfer a record, we need to be able to transfer the header data for a record to satisfy foreign key references. So it's like if I was referencing a contact, well, I'm not going to, the header data might be just the contact name. I'm not going to give them the birth date, the gender, the mother's maiden name, whatever. I'm not going to give them any of that data. I'm just giving them what we would deem as a header data, which is actually stored in the dictionary. Basically, this process allows a subscriber to update a record, that they have received from a publisher. So in a good example would be, let's say you had a hospital system, and that hospital system is getting patient data from a central source. Well, if that patient happens to pass away, they need to update that status for that patient right away in their system so they can take other actions. And so we need that ability to be able to update, and then when the actual update is communicated back and then comes back to them from the central source, they're notified that there's been a change. So we need...
Blair, can I just interrupt for a second? Yeah, in the sense of time, we want to allow for Q&A as well. So
okay, so how much time do I have? I'm just about done.
Okay, yeah, let you finish, and then I just want to make you aware of it.
Okay, what time do I have until Q1?
Technically, 3 minutes.
But, 3 minutes. Okay, well, I'll just do the last part, which is basically the application framework. So I am actually just about done anyway. And so the application framework is really the last piece. And, it really encompasses, security systems, menu systems, it's all those features that support our user interface. And we need to be able to create an application framework that's very much like a web browser, and parameterize more of the systems so that, so that we can be more insulated from technology changes, which will help us have systems last longer. And basically, it also allows us to exchange functionality between systems, and it will let us create really robust user interfaces, like and have things like that are multilingual. So that's really the 5 key principles, and so the real big goal is to have these 5 key principles be drilled into our new architects and developers, so that they can go and help organizations to create their own systems and deal with some of the efficiency issues, and really to help us to take advantage of AI and machine learning. So that's kind of the most of it. So did you want to pass on any questions or?
Absolutely. Let me look through them. And I'll say to anyone who's watching that if you have to jump, because it's the video will be online later, and so you'll be able to come back and watch the questions being answered. So first question is, How do you balance leveraging an open source community with security concerns?
Well, that is a really good point. I mean, you look at blockchain, blockchain was, is considered secure, and it's an open source approach. It's I guess the thing that I look at now, if we had a million systems that we've created, then, almost a million times developers and architects have created security systems within their systems. So imagine if we took that effort, that is duplicated across all those entities, and we started to focus it in on, a secure approach, and that we could collect those efforts, and then I think that that we would have a considerably more secure system than we have right now, where we have people that may not have any security background creating systems.
Solid. Deborah, I believe you have a question.
Sure, thanks, Nicholas. So this approach seems to, of course, start with the data instead of starting with processes.
Yes.
So that when looking at gathering requirements, the requirements don't start at the function. They start at the data. And then identifying the data, build the processes around that. And of course, as we know, processes are more volatile than data. So is that in effect turning the whole development process and requirements gathering on its head?
Well, no, I think that, data is definitely, there's workflow processes, that are involved in, there's a workflow component to, how we create these systems. But in the process, we are organizing data, that sits in our enterprise systems, right? So the processes are capturing data, and we're organizing this data into like an enterprise model. So, yeah, so,
so it's not a matter of where you start. It matters that data gets the same level of attention. In my view, systems engineers never think about data or start with data. System engineers always, they start with the process.
Well, that's right, and you'll see things like slides where they'll say data is the exhaust from applications, so which is not how we need to look at it. So it's really about helping the data architects to create their enterprise models that are normalized and provide the most efficient access in order to support the processes that are being designed by the business analysts. So
yeah, from my perspective, Deborah, look, data is the most reliable, consistent, non-changing element of the business. It's the one that's the most least changing, in the sense of the data that exists. If you're a car company, you're going to have car-related data. If you're a health organization, you're going to have health-related data. So that has to be the core element, and you have to start with the data first. My view is slightly different, and in that sense, the data models that we're proposing are industry-wide. They're going to be standardized data models that people can use and modify. There's in the design that we've got here, there's capability for those data models to be customized. And as more and more companies begin to use those data models, and there may be elements or attributes in the data model that become very valuable for every organization to have, and they can be then included in the core data model that people can just reuse for their own organization. But it still allows customization. But yes, I'm of the opinion that we start with the data first always, and that
right. So, but at the same time, the downside of a core data model is the perception that it will not allow for a differentiation of your company versus your competitors.
Oh no, just the opposite. I mean, like the core data models, a key aspect of them is that you can extend the models to, address your unique needs. So, like the financial modules as an example, you are extending it to capture data about the types of transactions that your organization does in the way that you want to do them. But at the core is the same. I mean, I could show you no, we don't have time, but so no, the models are not, they are extendable to meet unique needs, and probably more so than you think of an organization that implements a package system, and how much capability do they have to change that package system to meet their unique needs. So yeah.
Right. So we really decoupled the process and the data, and then we're putting it back together.
Yeah.
All right, and then with this new key situation, we enable an integration anywhere, anytime. Mm-hmm.
Across any organization and across any mergers and acquisitions as well, which is where we see huge opportunities down the road. But more than that, the design is flexible enough to allow for each company to have their what they call their secret sauce, or their unique way of delivering a particular service they want to deliver. It does allow that customization. It's just that it allows you much more rapid progression to building a new application. Because you have all these core data models, you start much faster. You're able to go in halfway instead of having to build right from scratch.
All right. And I can see that if companies actually adopt this, that with mergers and acquisitions, they could actually get more money for their companies with this sorted, as it were, integration capability.
Yeah.
Sure. Just imagine a company in the US or any other country buying another company in another country, and if they've got their systems designed in this unique model, you avoid, you have a massive rapid integration rather than having to leave the companies running their own systems on their own, because it's just too big a task to integrate the data. Plus, do we need, it'll be interesting from Bill's perspective, Bill Edmonds, to see if we'll need the data warehouse in the same way. If we've designed these systems in this way and we can pull all the data that we want, it'll be interesting to see how we can pull all the data for analytics indifferently. And maybe Blair, you might want to comment on that. Do we need a data warehouse in the future, or a data lakehouse?
Yes, I would say that we do, because with the data warehouses, yes, we can take data from all the smaller entities and roll them all up to the highest level for reporting. But we are also, lots of times in the data warehouses, we're denormalizing data, in order to, kind of improve our performance in terms of, doing queries on it. So there's definitely a data warehousing task to taking this data, denormalizing it, making it, time segmenting it, all the things that we want to be able to do to analyze it. So yeah, I still see there's a need for, definitely a need for data warehousing.
Performance is still the thing, yes.
Yeah.
These new keys that we believe will improve performance of systems rapidly and immensely. So, given the current systems and the way we design them, the issue is, how do we teach universities to start with the data first, and how do we get them to not teach silo development and to teach enterprise integrated systems development from almost the first class onwards?
If this presentation, my single goal with this presentation would be to have people step back, look at how they're creating systems, and recognize that they're creating them in a silo, right? And that as a result of creating them in a silo, we will always hit the wall when we try to integrate, and whether this is the right approach or some other approach is necessary. But, I think that we just need to see we are creating systems in silos. And
from what you're saying, it seems like you're really approaching this from an individual issue, like the way you're talking about universities teaching the students to focus on a data first and not trying to silo off systems. But what kind of strikes it for me is this almost sounds to me like it should be a top-down from a hierarchical point of view. Like the individual developers aren't really making a choice to silo off the products. They tend to just be working with what is already happening in an organization.
Oh, exactly.
So wouldn't the organization heads be the people that we're really focusing on? Because especially when you talk about university students, when they're joining companies, they're not really rocking the boat, right? They're not trying to create entire new systems. They're not saying, I should silo all this. They kind of are just falling into an organization that already exists with all of these things already happening.
You are definitely right. They're like, and the book is really targeting all levels, in terms of not just the architects, because of course, it targets, information for executives and like CIOs to be able to understand how we're doing it and why it's an issue and, why we need to change. So it is really, I totally agree. It's a top-down perspective in terms of actually implementing the change. I think what the hope would be that once organizations start doing this and start being able to exchange data with their suppliers, their customers, their partners, and we can start to see those exchanges occurring. I think it's going to dramatically improve their efficiency, and we will start to see greater adoption. But it's going to take time.
Yeah, and going to your point, absolutely, the people that are coming from universities are following models that are already in place. However, if a lot of times when the students are coming into the workplace, they're not always going into a production environment. Some of them are in startups, some of them are in unique situations. The issue is we've got to change the mindset both at the academic level and at the corporate level. And so you need to have a dual approach. So students coming into the workplace can say, yeah, this is, can we do it more efficiently? Can we help you improve it some other way? And they can certainly introduce those ideas to seasoned professionals. They may not have an ability to do it, but they'll certainly at least open up the mindset a little bit. So we do need a dual approach.
If we have time for a couple more questions. Do you see Microsoft's vision for Dataverse qualifying as a core data model? I think it's their intention versus embedded only in their ERP offering.
Well, here's the issue, I think definitely it's another one of these steps in the right direction. But if you take, so it's really centralizing the exchange of data in a central location. But you're still, if you're still constructing systems in silos where you define whatever primary keys you want, using whatever data structures you want, using, with no record governance, and you are creating those interfaces between your system and this Dataverse is going to be an immense effort. And we're going to hit all the same issues with trying to exchange, data between systems that we see now with who owns the book of record, trying to keep track of all the primary keys for all the systems that are trying to communicate with this thing, and mapping things like a well status when there's 7 well statuses in theirs and you got 3, and so there it's having this central mechanism is kind of, I feel like it's kind of like a shortcut process trying to deal with it and not getting again to the core of why we're experiencing these issues with integration.
Wonderful. And I know I've held everyone a bit late, but I appreciate it. So I'm going to ask one more question from the audience, which is, how do I create the new primary key when I'm collecting different bits of identifying data from completely different systems at different times? Like an email from a purchasing list, a phone number from a customer list, etc.
There would be, there'd have to be, kind of like import mechanisms. I guess if we were taking this data, and let's say we're taking this data and bringing it into like a data warehouse from a disparate source like that, when we, on that import process, we are basically, regardless how we were doing it, we're bringing it into a system. And it's really just, when we create that data, it's automatically getting assigned a primary key, and it's connecting with, using, kind of like the foreign key concepts. And yes, it is this process of, aggregating data from different systems, but to me, it's really the same process that we'd be following if we were bringing it into a data warehouse. We'd have to take that data, create records in tables, that are connected together with foreign keys. And the only difference is we're really using, the primary keys and foreign keys that we're generating with this new protocol. So.
And the approach that we're taking also is that, we want to allow organizations to take one system and incrementally move into all the systems. So they can just decide to do one function and implement the system, implement this approach within that business function, and then slowly move it across to the other business functions. So any effort in here, it will be valuable and moves them along that sort of line of complete integration in a much, as I say, low risk and incremental approach. I think Deborah had another question.
No, I just wanted to wrap it up for everyone, if that's okay. Thank you so much for this session. It's really been quite eye-opening with starting with data and not with the process and how to go about it. We look forward to your upcoming book with yourselves and Bill Inman. And also looking forward to more information on your open source approach to all of this. It could make a real difference in the industry. Thank you so much for your time.
Well, thank you for the opportunity to speak to this audience about this. We appreciate that.
So next month, watch for